Welcome back to Statistics and Mathematics YouTube channel. As I promised you the last time to work on an example on balancing complete block design, here is the example. Please, if you haven't subscribed, please kindly subscribe and like, okay, and then share the videos to your friends, right? So please, today we are going to walk through example of the balanced incomplete block design. If you haven't watched the previous video, please kindly go and watch it, because if you don't really watch the one I did on the formulas, you walking through the example will be extraordinary for you, right? So at the end of the day, please let's kindly go back and watch. So this is the example. Here it goes. It said an engineer in studying the Malice performance characteristics of 4 types of gasoline additives. In the road test, he wishes to use car as blocks, but because of the time constraint, he runs the design with 4 blocks in a manner that is displayed in the following table of results. So here we have our car as what blocks and additive as what treatment. Said analyze the data from what the experiment and draw conclusion using what appropriate design at what significant level of 10%, right? So before we will go through that, I want us to set our hypothesis before, because we are going to compare means here to find our F, so that we can use our F to draw conclusions, right? So for a treatment adjust, that's for the hypothesis for the treatment adjust. Our H naught is equal to U1 is equal to U2 is equal to U3 is equal to U4, and then our H, that's for our H naught, sorry, and then this one for our H1 is what? UI not equal to UJ for at least 1 pair, right? Yes. So at the end of the day, this is how things work for the treatment. That's for the hypothesis. When you come to the block, to same thing. H naught is equal to U1, U2 equal to U3 and U4. And then H1 is equal to UI not equal to UJ for at least 1 pair, right? Since they are all having the same treatment, their hypothesis will always be equal, right? And then we have the addict, so once you have given the question, just write the question again, and then just find your summation for the both rows and the column for the individual block and treatment. So when you take block 1, you're just going to add the 14 plus 12 plus 13, right? And then when you take the 2, 17 plus 14 plus 11. And when you take the 3, 13 plus 13 plus 11, 13 plus 13 plus what? 13 plus 13 plus 12, and then you get your solution, right? So at the end of the day, and then you just go to add the same thing here, right? Once you add the blocks, and then so this is what you get for the adding of the blocks, right? Sorry, here was supposed to be 14, but I did it 13, right? So here is supposed to be 14. So this is how, once you add this one, this is what you are going to do. And after that, you add the addictive levels, right? So when you come to 1, you just add everything, you get 44. When you come to the 2, you add everything, you get 41. When you come to the 3, you add everything, you get what? 37. When you come to the 4, you add everything and you get what? 35. So once you are done, you are just going to add the individual the individual summation for the rows and the columns, right? So 39 plus 42 plus 38 plus 30, and then 44 plus 41 plus 37 plus 35. You are surely going to get 157, right? So that 157 is you are going to use that one for the I dot, right? The I dot is equal to 157, right? We are going to use that one for that, since the 157 is the addition of all that we have here, right? So you setting up this table will make your solutions very, very simple, right? So here you have sum of square total. So before we can get our F, we have to construct analysis of variance table. And for the analysis of variance table, we have sum of square total, sum of square treatment adjust, sum of square error, and sum of square block. So you have to calculate them manually and then draw the table, and then that one will help us to find our F, and we compare it to the critical value to make our conclusions, right? So the sum of square total is shown in the formula above. In our last video, I explained on that, I touched on that. So if you haven't watched, go and watch. So this is the formula that we have. So the Yij is just going to take the individual Yij square is just taking the individual value observation that we have and the square. Once you are squaring, then you'll be adding. Here we have 17 square plus 14 square plus 13 square plus 14 square plus 14 square plus 13 square plus 12 square and the rest, right? So once you square them, then you subtract it from what? The Yij, right? Dots. Sorry. the y dot dot, right? The y dot dot is what I told you is what 157, right? Yes, so 157 all square divided by what our n, right? And you see our n, right? Our n is giving us what bk, or you can use what ar, right? And we say that our a is what the treatment, right? And then our r is the number of times our treatment occur in what and a design, right? And our b is just a block, right? And our k, the b is block, and then our k, we just explained that our k is the k is the number of treatment in a specific block. So we are going to use the bk to find our n, right? You can choose to use your ar, right? But for us, we are going to use our bk, right? So our b here, how many blocks do you have in this one? We are having 1, 2, 3, 4 blocks, right? So our b is equal to 4, and our k is the number of treatment in a block, right? So when you come to here, we are having 3 treatments within what block 1, 1, 2, 3, right? So when you come to the 2, 2 is the same thing, 1, 2, 3. When you come to the 3, 2 is the same thing, 1, 2, 3. So our k is what 3, right? Our k is equal to what 3. Once you multiply the k and then b, you are going to get what 12. That's the reason why you see the n here to be 12, right? So that is how things work out for the n. And I've explained that one in our last video. So go and watch that one. If you are not getting it, go and watch it before you come to the calculation aspect, right? So when you square this one by one and then when you square the observation one by one and add, we are going to get when you square the observation one by one and then add, right, and subtract it from 157 squared divided by 12, we are going to get 347 divided by 12, right? And then in decimal place, we are going to get 28.167, right? So take your time and then punch it inside your calculator one by one and then subtract it from this one. We are going to get this answer, and then in decimal place, we are getting what this one, right? So that's sum of square total, right? The sum of square block is 1 over k summation 1 over k, right? Summation, I think this is having one summation sign, right? I'm sorry. So 1 over k times, right, summation of the individual blocks all squared minus y dot 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 squared divided by n, right? And then the y dot j, I told you, is the summation of the individual blocks, right? So when you come here, you are just going to take this one, 39, 42, 38, and 38, right? So when you come here to the 1 over k, the k2 is 3, right? Bracket open, that is the summation all square. So 39 square plus 42 square plus 38 square plus 38 square. That was what we got here, right? So we are going to just square and then add, right? Minus what? Our y dot all square divided by n. That's 157 square divided by our 12, right? So once you add all this and subtract from this one, subtract this one from this one, I'm going to get 43 divided by 12, of which our answer for the block will be 3.5833, right? Yes, so we have to be able to also calculate our sum of square treatment adjust, right? Sum of square treatment adjust, right? Is equal to k summation of is equal to k times summation of what qi all squared divided by lambda a, right? And we know right now we know our k to be equal to what 3. We know our lambda, we don't know our lambda, but we know our a to be also be equal to 4, right? Because a is what the number of treatments, right? A is the individual number of what treatment that we have. So 1, 2, 3, 4. We are having 4 treatments here, right? So we are supposed to find our qi. Once we are done with the qi2, we are also supposed to find the lambda before we can also find out for our sum of square treatment adjust. So some things here is a little bit dicey, so kindly take your time and then listen to me very, very careful before you can get this one, right? So in our last video, we learned something on this one, right? We learned something on how we find our lambda, right? And then we said that our lambda is equal to r into bracket k minus 1 divided by a minus 1, right? So our R is the R here. We have just explained the R, and then we have explained the K and the A. So R is equal to a 3, right? Our R here is equal to 3. Our K is equal to 3, right? Our K is equal to 3, and then our A is equal to a 4, right? So for the how we got the R, this is how we got the R. So the number of times a treatment occur in what a design. So when you come here, when you pick the row 1, you see that 3 is what it's occurring 3 times in the design. When you pick row 2, it's occurring 3 times in the design. When you pick row 3, it's occurring 3 times in the design. When you pick row 4, it's occurring 3 times too in row 4. So at the end of the day, the R is equal to 3. Bracket open K. K2, I have taught you how you find your K. So you just 3 minus what? 1 divided by 4 minus 1, right? And then you'll be getting 3 bracket 3 times 2 divided by 2. Sorry, 3. This one is going to cancel this, and at the end your answer will be equal to 2 for the lambda, right? So once you have this parameters, you just substitute it inside. The formula to get what your lambda, right? And then for the Kij2, in our last video we discussed how this Kij works, right? So if you haven't watched that video, please kindly go back and then watch it, right? So our yi dot minus y1 divided by k, summation of nij times y dot j, right? The yi dot, right, is the summation of an individual treatment, right? So we are going to pick it if we want to work for this one. Let's say, for instance, we want to calculate the treatment adjust. We want to calculate the adjustment for row 1, column 1, right? That's the adjustment for row 1, column 1. So for row 1, column 1, we are going to take take the summation for the individual treatment for row 1, and then take the summation, and then once you take that one, right? When you come this part, you come to this part. So as you have taken that 44 for the treatment, then you come to the block, right? So the block that where the missing value is, right? This part is going to be cancelled, right? And then you take that one and then add this one. So when you come here, you will see it clearly here, right? So minus 1 divided by k, summation of what? 42 plus 38 plus 38, right? So we could see that the summation, once the missing distance is in block 1, row 1, we are going to take the row, right? We are going to take the individual treatment for that one, subtract it from 1 minus k, and then we are going to delete this one from the summation. So here will be 42 plus 43 plus 42 plus 38 plus 38, right? So that's how we are going to solve for this one. 42 plus 38 plus 38, and then the nij, right, is going to be 1, right? We are going to assume that the nij is what? 1, right? So 1 times this one is surely going to give us 1, right? So once you do this one, you're going to get 14 divided by what? 3, right? And then let's go to a Q23. That's the next missing distance, the next missing value in the design. So Q23, right? So for the Q23, we are going to take the individual summation of that individual treatment. That's 41. And we are going to subtract it from 1 divided by k. So that one will be 1 minus what? 3. And then summation of what? The nij is also going to be 1. And then we are going to sum, right, the rest of what? The block. So we are going to delete this one from the summation. So this time around, the summation will be 39, 42, and then what? 38. So as we come down here, right, so here will give us 41 minus 1 over 3, 39 plus 42 plus 38. Once we sum it, this is, once you point this on the calculator, this is what you are going to get as your answer. So our next missing value on that is 32, Q subscript 32, right? So Q subscript 32. So column, we are having row 3, column 2, right here. So for row 3, column 2, right, we are going to take our summation of that individual treatment and subtract it from 1 over 2, sorry, 1 over 3, that's 1 over the k, and then we are just going to delete 42 from the summation. So here will give us 39 plus 38 plus 38, right? And then our nij is equal to 1. right? So when you come here, 37 minus 1 over 3, 39 plus 38 plus 38, and then we are going to get negative 4 divided by 3, right? And you are going to do the same for the 4, 4, right? So here we are going to get the Q subscript 4, 4. We are going to take our 35, subtract it from 1 divided by 3, bracket open. We are just going to delete this one from the summation. We're going to take 39, 42, and then 38, right? The reason why you do that is that where the missing value is, sorry, the block that the missing value is inside, that's that block part. The summation of that block is not part of what you are going to take, right? So when you come here, we do that one too nicely for the Q 4, 4. So I'm going to get 35 minus 1 divided by 3, bracket open, 39 plus 42 plus 38, right? And then you are going to get negative 14 divided by 3. So once you have gotten your Q 1, 1, Q 2, 3, Q 3, 2, Q 4, 4, and then Q 4, 4, then it will be very simple for us to calculate our treatment adjust, right? So here the R that we see here, sorry, where is the distance? So this is our K, right? So the K will come, so that we know that our K is 3. K is 3, so that one will be 3, bracket open, of what the summation of what we have for this one, the missing this is, so 14 divided by 3 plus 4, right? So as you can see here, 14 divided by 3 all square plus 4 divided by 3 all square plus negative 4 divided by 3 all square, right? Plus negative 4 divided by 3 all square, as you can see there, right? So at the end of the day, we are just going to take the individual KQ values that we have and then substitute it here and then square them one by one and then divide it by what? Our lambda A, right? As you see here, this is our lambda A. And lambda 2, we got our lambda to what? 2. And then our A initially was what? 4. That's the number of individual treatment, right? It's what? 4, right? So at the end of the day, this is how we can get our sum of square treatment adjust, right? So once you point this one in on your calculator, you're going to get 53 divided by 3, right? And then our final answer will be 17.6667, right? So you see our sum of square error, right? The sum of square error can be just be calculated using the sum of square total minus sum of square treatment adjust and then minus sum of square block, right? So once you do this, you are going to get that, and then once I subtracted from that, I got 7.667, right? So we just come and form another table for the treatment block error and total, right? And then put the respective value for the SS inside. So here we got 17.66. We go here to the 3.5833. We go here to the 7.667, 28.9167, right? And these are the respective degrees of freedom, right? So you see the degrees of freedom for the treatment was what? A minus 1, which is 4 minus 1 is 3, and this one was B minus 1, right? And the B minus 1, 2 is the B minus 1, 2 is what? 3, and then here we had N minus A minus B plus 1, and then we have 5, and then the total was N minus what? 1, which is 12 minus 1 is what? 11, right? And then we just divide this one by this, we got that. You divide this one by this, we got that. You divide this one by this, we got this, right? And if you want the F, right, you are just going to divide it by the error, right? So we are going to divide the treatment adjust by what? The error, divide the treatment adjust by the error, and we got this one. So this is our final answer, right? So we have 3.8406, right, for the treatment, right? So here our main focus is to make conclusion for the treatment, right? So here our critical value will be alpha. This is how you find your critical value, right? This is what F calculated. This is how you find your critical value. This is F alpha, comma the treatment, comma the error, right? The degrees of freedom for the treatment and the error, right? So this is how it works. So when you go to the F table, you check for the F table that contains alpha of 0.0. It's not 0.05, right? But I'm sorry, I think here was 0.05 according to the question. The question was using 0.1, right? I made a mistake there, so here is 0. I'm coming a minute. 0.05, right? Alpha level of 0.05, right? So when we come here, once you read this one from the table, we are going to get. So you just trace F table and then look for the place that the alpha is 0.05, right? And then at the end of the day, we just use the 3 for the V1 and then the 5 for the V2, and then just locate where they will merge and then get your critical value, right? So here will be 3.62, right? And then we just make our conclusion. Since the F calculated is 3.840 is greater than the critical value, we reject our H0, right? And then just conclude that there is a significant difference in at least 2 of the adjectives. So here we will bring the class to an end. In our next video, we are going to continue in the design. So kindly go and watch that design. Thank you.